Good morning, Nick.
Afternoon.
Oh, yes. You're right.
Are
Well,
you
I
all right?
have the what was that?
You all right?
Yeah, yeah. I was gonna say I have the benefit that I still have my morning coffee here.
Ah, yeah, nice.
All right. I think we're gonna have a small crowd today. Sage is out, and Josh has some kind of uh awful meeting he has to go to. I think. Looks like we're getting a couple of other folks in at least. Might be small crowd today though. And I have to confess, I didn't get all the way through all of these pull requests this morning. But the good news is that now that we're going to start marking these things stale, at some point, these are going to fall off and go away, which will make my Thursday mornings much happier. All right, let's go through this stuff. There's one new pull request that I noticed this week from Radek. It's a slight optimization for bounding code. Radek, is that interesting at all, or is there much going on there?
Uh, Hello. Yeah, it's it's basically a side effect, a side quest of the buffer list work. Uh, Actually, it has two commits inside. One minimizes the allocation needed to STL containers serialization, but by only by 4 bytes. Second one is just make some optimization easier for compiler, especially on std list, where empty can be very can base on very different part of the internal data of std list than the size method. Also, I have a bigger branch of the Denk work. Basically, I've got impression the bounded the bounded encode result for bounded types basically should depend not on an instance but on class. It does depend on instance, more likely only because we want to have the ability to write everything using the nice denk macro. Uh, well, I after after key after reworking, I can see there is that the branching is during STL container serialization is removed entirely, but I'm not entirely sure whether we want to introduce such huge number of changes only because of one single branch. Let me provide link uh, the to the code. I mean, the second branch that doesn't have pull request at the moment. Here it is. But to be honest, I think that killing single branch is not worth such changes.
Ooh.
So I went with very small pull request that exchanges only emptied to just from STD, for instance, from STD list empty to STD list size that must use the same data underneath.
Sorry, Rack, I'm half paying attention, also trying to get through all the rest of these
No problem.
PRs here. But
Well, basically I've sent the pull request later as a cleanup,
okay.
not as a performance optimization. Of course, it has some small performance effect or impact on performance, but I guess it's mostly cleanup.
Okay, cool. Reddick, as long as you're talking here, I noticed that Sage. It looks like Sage merged your string processing stuff on the right path.
Do you mean the branch with that kills some debugs plus STD string stream on the right path? Yep, I
Yep.
saw.
The
Thanks.
24.3.12. So that's
Yep.
good.
Small changes, but visible, pretty visible effect, I guess.
Whatever happened? Speaking of debug related stuff, whatever happened to the debug MS1 crazy amount of work that we were doing there
We are still
for all
doing
the
it on
debugging?
our defaults. There was there was a discussion on Ceph Devel, and finally no conclusion. It seems that some people want to preserve, some other are not interested in the information. Who knows?
If I remember right, Greg, you were one of the ones that really wanted to keep that there for debug MS1, right? All the info that we were collecting.
Sorry, my internet just hiccuped.
No
Me to
worries.
keep what?
So a while back, Radek had seen that for debugging, debug MS1 was actually the biggest consumer of resources due to all that stuff that we collect. And I think you were one of the people that really wanted to keep it reporting all of that at level 1.
Yeah, we definitely use the message in and out to track down when things are breaking.
Is
I
there
don't know how much-
anything? Go ahead.
I don't know how we can get rid of some of the data that it's outputting properly. I'm just not sure how much or how useful it would be to try and get rid of like half of what it outputs and only keep the other bits.
This came up in this RBD sprint testing that folks wanted to do, where one of the things that I had done to improve performance on NVMe was just kind of blanket disable debugging, more or less. And there was interest in why that, in addition to a couple of other things, made a big difference in some of the tests. And it most likely the only thing in that might have really mattered was probably debug MS1, because it sounds like everything else is kind of not that big of a deal, relatively speaking. So yeah, I don't know what the right way out of it is, but it's gained some visibility, I guess.
I mean, okay.
Well,
I don't really have any idea what the relative trade-offs are. It's just like a lot of time. I mean, I don't know how common it is versus other things, but when something goes wrong and you're like, why isn't this thing happening? And then not being able to see the messages that come in and out is bad because we need to see what messages happen. Now, it could be that there's a more efficient way to dump them. It could be that we can, do a partial decode like we do with the, I think the OST op gets a partial decode, so on like message receipt, then it's kind of a truncated one, but just enough to see that it like appeared. And maybe we can do more of that with the others, but that's the like instruction passing system for Ceph. So we can't just say, nope, you don't get to see what it does anymore when it's communicating with other demons. Like we need to see that somehow.
Like you said, though, maybe quantifying or rating the relative importance of all of that info that it gives you. Maybe we could, like, at least if we really care about everything that's there, then at least we then can say all of this really, really is important, and make the argument that it's worth the performance trade-off on a really fast device to get it.
I vaguely remember it coming up, but it also was not clear to me like why that one mattered as compared to all of the other debug output that gets generated a lot. Like, is it just that on a default config, that's the only, like, basically that's the only thing that does anything? Because we don't jump a whole lot in default state, but it's not the only thing that happens. Or is it that for some reason the way it's being dumped is particularly expensive and we can look at the way it's being dumped? Because I thought it was just, I kind of thought it was just, like we do a lot of string manipulation for those, and so we should like change that. Not that we should turn it off. But I haven't made any effort to look at it.
The problem, if I recall correctly, the problem was, well, there was many reasons for performance impact, but the most significant one was in the crafting of the prefix debug dout prefix we have in all our messenger logs, and there was a call to get host info, if I recall correctly, performed for each message.
Okay, so that sounds like it's something that's really easy to I'll get fancy words.
Yes,
really
we can fight
answer for and just keep it for the thread and like point at it whenever you need it.
Sure, we can fight with the overhead by introducing more complexity. Definitely, we can. However, the simplest way would be just to change the default level for the debug MS.
Yeah, but if we change the default level, that means that anytime a crash happens, we don't have any idea what messages came in or out of the system, unless they made it far enough to start dumping other debug data, which a lot of times they don't.
Okay, sounds like this particular debug is really important, and because of that, we need to treat it as essential complexity. So maybe caching will do. But caching is always if you got caching, you need to take care of caching validation, etc., etc. But okay, we can do it.
Well, no, I mean that one's easy because the lifetime of it is just the lifetime of the connection, right? So, like, it's just a static member as far as the object's concerned. But yeah, I mean, because like these are the way you do, like, you pass any instruction. So you can't, like, you have to know what the instruction was, or else you're have to try and reverse engineer it from what you see later in the logs. And if it crashed on an instruction before you see the instruction, then you're just like, oh, yep, a message came in and something crashed. Or maybe you don't know a message came in and something crashed.
However, do we use, is that usage scenario comes from production clusters or is only our way of investigation?
Well, that's
I mean, do we investigate?
Is if you crash in a production cluster, then we dump out like all the in-memory logs. so that you have something to look at other than a backtrace, right?
Yep.
So if you have all the messenger debugging completely turned off, which is what you're talking about, then all you have basically is a couple things that happened in like Blue Store and the op work queue, maybe in the OSD. And a lot of times the thing that crashed was before it was like during fast dispatch, or it happened in the op work queue, but the only thing that told you what the op work queue was trying to do was when the message came in, because it hasn't printed it out yet. Because it hasn't gotten that far. I mean, you can talk to other people and see if they say I'm crazy. I haven't seen, like, I'm not the one who investigates most of these anymore, but that's definitely my experience with stuff and especially in the MDS actually. Now that I think about it, but yeah, I don't think you want to get rid of that.
I see. I just asking because, well, it might be that collecting all logs is perfectly fine if you target, well, 100 IOPS from device. But I'm a bit afraid about our transition to very, very fast devices where just the paradigm is changing, that making that investing so much resources in debugging wouldn't be our way to go. I mean, especially about the sister, about the new messenger.
Way of logging and everything for that, and talked about it a lot, but I don't want to rehash it today. But I mean, that's why we got the LTTNG stuff going, and
LTTNG won't resolve this issue. I'm terribly sorry. I made it. It won't.
I know.
It still does stringification, and it still limit. It has to do the
and that's why we need
stringification.
to figure out how to avoid the stringification, and I know that's a thing, and it's a whole big thing, but
Without rehashing the whole argument here about all of this, could we just bring it back to, are there any specific simple things we can do to reduce the amount of work for this specific log message? Let's just bring it back to that. Like, without whole new logging frameworks, is there any extra information that's there that we don't need to process? And are there really simple, specific things that we can do just to?
Mark, let's start from introducing some caching for expensive libc calls. I think that's the first step.
Okay. Greg, does that sound reasonable?
yeah, that's an obvious thing to do. And
okay.
Information going out.
Cool. So let's do that, because it's something that's visible higher up to people in the community and elsewhere. So I think it would be well received if we could in some fashion make debugging, if this is really the biggest impact is debug MS1, then I think it'd be a good thing to do. Cool.
However, that will be the first step. But I guess the very last one would be to reiterate our approach to logging in C-star world. LTTNG has very serious restrictions. First of all, you can log your recording macros can take only C types and can take only 10 parameters. So it's definitely not enough to binary record all the stuff we have, even when capturing single GH object T instance. This means we need to take serious rework of the idea of logging in Ceph in the new world, in the C-star world.
Yeah,
I know that
I hear you,
Sage
Radek.
is, well, there was already some ideas to employ our current encoding stuff, generate binary stream for LTTNG. However, this would impose some dedicated log reader, well, even more complexity. Sage was pretty fine with just making much better selectivity with LTTNG. However, better selectivity, ability to turn each single log message separately from other, this won't resolve the issue with things like the three, if I recall correctly, places we have in Messenger.
Braddock, in the C star world, I mean that's all kind of so far off anyway. I wonder if I guess I wonder if it's hard, if it'll be hard for us right now to think about this and kind of what logging and just kind of uh, uh, understanding what was going on in the cluster, if it's even going to be kind of difficult for us to wrap our heads around what that looks like until we actually have the C star code kind of at least in a semi-functional state. Does that kind of make sense?
Yeah, we'll need to we will need to just we'll need to make decision whether we want the very basic, very first one, whether we are interested in recording a cluster that we think behaves correctly. Well, pre-logging basically. Yes, pre-logging is quite good wording here, I guess. Whether or we just want to run without any logs by default, and then start enabling them if we need to make some investigation.
I mean,
It's not about implementation. It's even it's about the it's about functionality basically.
I will say that when at the supercomputing institute that I used to work at, that is the way that we ran. We disabled all logging and debugging and anything else with Lustre. This is kind of before Ceph was really stable. And that is probably not really representative of most users because we were just chasing the kind of highest performance we could get. But there at least are a class of users out there that want to work that way, probably. So we should at the very least make sure that it's fairly easy for them to get that behavior. Right now, going through and disabling like 30 different debug subsystems is not convenient. But yeah. Well, okay. I think we've beat this to death, so let's move on. Unless anyone objects. All right. What else do we have here? Okay, well, we still got like 2 other PRs. This increased cache size in the Mon, Sage merged it. I'm not particularly thrilled with just kind of, I don't know. It's fine. It's probably the right thing to do short term just to make sure that it's bigger. But it would be nice if we could have everything kind of work the way that we're trying to make the OSD work now, where you just tell it kind of a size that you want it to fit in, potentially because I guess we're going to run it inside a container someday, and just have it kind of conform to that, assuming that there's some reasonable default minimum, I guess. And then we also have this RDMA thing that closed because it's old. Thinking about that, I guess Kifu must have some insight into it because he closed it. Okay, Radek, there's this backward iteration in buffer list. It sounds like you talked to Josh about it and he liked it, and Greg, you reviewed it and approved it. Everyone's good with this?
I hope so, but Kifu points out there's a very, very important thing we cannot forget about. It's bumping up our SO version before next release.
Yeah, I figured we were gonna do that before it merged.
Well, maybe I will just append a commit to the PR, just increasing the number. However, I have no idea where to find the SEO version. Is there any hint, maybe?
Yeah, I'm not sure. um, this might be something that we want to do after Kifu's split of the C and C++ bindings comes, because there's also like the
Okay.
numbers that are in one of the Librettos headers that you can change the version numbers on, but I don't think that automatically turns into anything with the packaging. So yeah, maybe block it behind Kifu's. By the way,
Okay.
my
Anyway,
invite for this no longer has the Etherpad link on it.
No. Okay. Um,
Okay.
who?
But
All right, I'll look at that later.
yeah, no, it's just
Get
I
it
was
fixed.
doing didn't have a quick link, so there it is. Hello.
Is the Etherpad? All right. Other updated pull requests. There's a librd one that's being updated for this reduce the token bucket fill cycle and support bursting IO configuration. I'm pretty sure Jason's looked at that now, and there's been some new commits. And sounds like Peter is setting up a new benchmark lab wherever he is to look at this OpenSSL API refactor in crypto. So that's good. Hopefully we'll hear more from him soon. And then this last one, how to test OMAP. Doug wrote something, but I think it's very, very focused on deletes. I personally am kind of thinking about going in and trying to expand Rados Bench to support mixed workloads. So let it do a combination of writes, reads, and deletes, and kind of just give it the ratios that you want to do. I don't think it would be too terribly difficult to do that. So that's kind of what I'm thinking. But we'll see what Doug says if he wants to get this other tool that he wrote in. It's really old. It's been there for like a year, so I don't know what the holdup is, why it never merged, or if anyone cares if it merges or not. But anyway, that's that one. And there's a couple in the no movement category. There's a couple of newer things here. I still need to fix my cache binning thing. It keeps getting pushed off working on other stuff, but one of these days I need to get back to it and just fix whatever's wrong. I mean, it's a lot of code, but overall it seems to work fine on my platform. So I need to understand that. What else? There's this container slab allocation thing. Is that Radek? Is that still ongoing, or are you kind of like?
well, I
backburnered now?
self-reviewed it, but I would really appreciate more comments. I would appreciate reviews. I plan, well, the pull request already has some appliances of the slapped slapped containers. I'm considering using also slab allocator in the reworked buffer list, but that's another story. Still, I would
That also
really appreciate any review of the slapped PR.
that reminds me too that another thing, now that we're using our own implementation of the RocksDB cache, we need to get that into the mempool infrastructure, and maybe it would be worth looking at memory allocation strategies related to that as well.
Well, I'm not entirely sure we want to glue the things to the very often used things to mempool. Okay, it started, but during the work and the slapped containers, when I put slab containers glued together with mempool, I saw really significant regression in performance. I put some comments with the results. It was well. I saw that CPU usage has grown from maybe the function used, the method using the stuff started taking maybe 4 or even 4.5% of CPU of cycles instead of 1% or 2. Mempool
Do you
is
remember?
in. Let me find.
Okay. If you see it, great. That's unfortunate.
Well,
That
the regression was also caused by a pretty significant complexity we have in the allocator itself. But even after the rework, it still was significant. Maybe 1% of CPU. Well, I was surprised because our sharded mempool isn't actually so.
Sorry, you cut out there, Radic. Isn't so what?
So cheap, so fast.
Okay. Well, maybe while you're looking for that,
Well, we could actually employ absolutely the same idea we used for perf counters rework. Basically, we could predefine plots with counters, give each thread its own if it's still available, of course, and then make the additions and the operations anatomically.
okay.
Got link to the comment.
Okay, let's see here. Radic, let's talk about this outside of the meeting because I'm not I don't have the attention span at the moment to be able to look at this real well. But it would be really nice to be able to keep using the mempool infrastructure for the Bluestar cache and something like that for the RocksDB cache. So it'd be worth it if we can make it better, I guess. It's definitely kind of the way that I'd like to be able to go for the RocksDB cache, just so that we're actually accounting for it, and kind of.
How many threads usually touch the RocksDB cache?
Presumably, yeah. Plus the KV sync thread. Plus, I suppose all of the RocksDB threads that do background compactions.
Oh, okay.
Yeah, lots of things, actually.
Definitely.
Some of which we don't even control ourselves well, right?
Yeah. If you want to glue that caching structures together with mempool, well, we should expect there is a risk of regression.
Okay.
However, maybe it's just worth just trying, just to judge the regression.
How bad it is. Okay. All right. Yeah. Okay. I don't think there's too much point in talking about any of this other stuff right now. Okay. The only other thing I had is that I'm looking at. There's a lot of desire right now to understand OMAP performance. And since I'm already doing a lot of stuff with RocksDB anyway, I thought, oh, I can take a look at it. So the gist of it is that we do a lot of work for OMAP writes. On my dev box, it's about the same no matter if you're doing like 128 byte or 512 byte or even like probably 1K OMAP writes. Anything in this region kind of seems to perform or behave the same. We have a lot of CPU overhead. A lot. It doesn't necessarily look exactly like it, but each TPOSD TP thread is spending a fair amount of time, like 20% of its time active, and like a third of that is in primary log PG, just doing work, lots of work. We also see some time spent in like just creating and destroying and dealing with transactions and other stuff. I've got a profile here that I can probably include somehow. But yeah, the gist of it is that we've got a lot of TPOSD TP threads. I think 16 in the trace I just grabbed by default, and each one of those is doing at least some amount of work, and all told it's a lot. So file store is actually worse. There's some extra translation stuff in there that I didn't even know about. I think that was showing up in the trace that I looked at. I took one for file store. Also, oddly, there was actually some PG lock contention, which I wasn't exactly expecting to see. But yeah, file store was, I think, getting like 1.5 to 2,000 writes per second using 5 cores to OMAP. for 512 byte OMAP puts. So in any event, it's a lot. It's working very, very hard. It's not entirely just RoxyB. I mean, RoxyB is also working hard, doing compactions and moving stuff around. But I think probably the bigger issue is just all the like encode work that we're doing, object creation, destruction, just lots of stuff. One of the things that I've kind of wanted to do for a while has been to just implement a really stupid PG class, one that doesn't do recovery at all. I mean, in the past, I've just like removed log operation from primary log PG and a couple of other random things. Make sure there's no dubop detection happening. Make sure that PG info isn't being written out. This kind of stuff, and it made a big difference. I mean, I was testing Pet Store at the time, which is just a really fast implementation of the mem store, basically, or it was when I was playing with it. And it was when you take out that all that stuff, it like halves the CPU usage. And I imagine for here it might even be a bigger effect, just based on what we're seeing in this trace. But I tend to wonder. I guess my personal suspicion is that log-based recovery on really, really fast devices doesn't really make sense. I don't know. That's my thought. But so personally, I'd like to try to start out by making a very simple PG class that doesn't do anything. Does that seem insane to anyone, or good, or bad, or whatever? I hear no feedback, so I will assume it's a terrible idea. We'll see. Anyway, that's what I'm looking at right now. Anything else, guys, from anyone else?
I've just got a couple of things. Just continuing what I've been talking about last couple of weeks.
Yes. Go
Go
ahead, Nick.
I'll just share the screen quickly. Is that showing?
It is.
Yeah. Okay. So it's just the deferred write. So I think I got slightly on the wrong track originally because of those counters showing different things for new writes and small writes. But I've been looking, and the difference to me seems to be mainly between random and sequential. So you can see that's random writes to hard disk with RoxyB on SSD, and that's sequential. So you can see there's quite a difference. But interestingly, the minimum latency time is actually quite close. And this is just like a pure SSD. You can see, again, that minimum is very, very close. Average is a little bit higher. I suspect it's sort of bouncing around some sort of queue limit or something for doing deferred writes, which is why, although the average is lower, the minimum is sort of all roughly in the same area. So I'm continuing to look at that. And I mean, I posted this on the mailing list, but down the bottom there is sort of what I was or sort of seeing with FileStore on a slightly different cluster, but with hard drives. So that there's potential, I guess, as long as, in theory, you should be expecting for low queue depths to be getting similar latency to an SSD. That's, I guess, what the you should be aiming to get. So I'm going to keep looking at that and see if there's anything I can tune in those regards. If you're interested, I've just got a couple of other real life captures I've done from as I've been upgrading our next cluster to BlueStar, just how the performance is sort of impacting from more of a external view, if that's interested.
Sure.
So one thing I've really noticed is stuff like cleaning up snapshots and doing FS trims. With FileStore, you tend to get this massive disk utilization, and this cluster's got about 200 OSDs, but even so, doing an FS trim would just sort of pin the disks. It's sort of like quite a high utilization for, half an hour or so. Where with BlueStore, this is taken on the same cluster. You didn't even really notice anything was going on. So I'm guessing that's some enhancements in the way that RocksDB has been used to manage the all the metadata rather than level DB sitting on the spinning disk. So that's been a massive improvement. I've also just got some graphs just showing the resource usage before and after, going from FileStore to BlueStore. Overall disk utilization seems to be slightly lower. I think quite a big one as well is where you had quite long queues on FileStore, certainly with writes. That's a lot more contained in BlueStore, so the maximum queue length seems to be a lot more limited, so that has a lesser impact on read latency. Memory, so these were 8 terabyte disks. You can see in this purple bit here the amount of memory that was being used for Slab and other file caches has absolutely been slaughtered down. Overall, the commit is slightly higher, but that's not a problem at all. So that's been quite interesting, because the Slab was always something that was a performance limiter, because if objects weren't in there, it was quite a heavy latency impact when doing reads or writes to those objects. And just a couple other things I've noticed. I think this is because it's using LVM now, but I/O sizes seem to be limited to 0.5 meg. I noticed that during recovery that the maximum I/O size seemed to be limited. Not potentially an issue, but I thought it was just worth mentioning.
Can you adjust the sysblock max sectors KB limit?
No, so I did try that, but it seems there's something in LVM or device mapper which actually limits that. I did find some other not Ceph related, but some other mailing list posts, something to do with LVM, where somebody was saying the same sort of thing, that you're sort of capped at a certain size. The only thing I was wondering if that was potentially limiting recovery performance slightly, because you're forcing smaller IOs down to the disk rather than writing out in 4 meg chunks, which is obviously a bit faster for spinning disks. Not a massive issue, and in fact it could be a positive, because you're not in the situation where you're waiting for a whole 4 meg IO to complete. If they're being split up into smaller ones, it's sort of better for a sort of a quaz scenario where you want to try and insert other IOs into the middle of other ones.
Sure.
But hey, so I know I brought this up probably about 6 months ago when I upgraded a cluster to Luminous, that scrubbing was having quite an impact on latency where it wasn't in Dual. And that was because apparently an issue had been found where scrubs weren't taking PG locks. I think Sage said there were some improvements in this in Mimic, possibly, although it's still quite a large impact. This maybe is just something you have to live with, but it does mean that obviously any IO going to that PG is waiting on a scrub to complete, which could be on a spinning disk 10, 20 milliseconds or whatever. Which, when you look at that deferred write stuff, it has an impact there. Because I guess if I'm looking at it, if you were looking at like a traditional storage array, you've got the caching layer right at the front of the stack. So it doesn't really matter what the latency of the backing disk to do, and you've always hit that sort of very fast memory. When you're looking at this and you're starting getting 20 milliseconds queued up for a scrub to complete, that does sort of have an impact on stuff which is expecting to be able to do low latency stuff. Other thing, I've been testing a bit of Erasure code and overwrites. Performance is actually really good until you actually start saturating the device. So what I've been seeing is that typically once you start getting near, I don't know, 256K, 512K IOs, because the time to write those IOs onto a single disk starts to get quite high. When you're splitting those IOs into smaller ones across multiple devices and doing them in parallel, the performance actually starts to become an increase, which is quite good. And that's all I've got to report. I hope it was useful.
Did you ever look at EC reads?
So they are. I think that's the only case that's like basically slower, because at the moment it can't. Or certainly, sorry, for a big amount of data, it's faster. But for any sort of smaller, probably up to about maybe 512 to a meg, it's slower because you end up having to wait for all the OSDs to, certainly spin this line up and retrieve the data.
Yeah. The little tests that I did, that I've always done, or that I've done previously on EC with BlueStore, BlueStore actually for large IOs was faster than doing 3x replication. It was somewhere between like 2x and 3x typically for large writes. For really small writes, it gets slower. The smaller you go. But for reads, that having to read from every single OSD participating definitely made it slower than replication, where you're just reading off the primary.
Yeah, no, I mean definitely. I mean, I think certainly smaller eyes really, really suffer. Larger eyes, it's not, certainly on spinning disk, isn't too bad because the time it takes to maybe read 1 meg off 4 OSDs versus 4 meg off for a single, it sort of makes up for that. But certainly with the lower, smaller IOs, I've seen an issue.
Yeah.
And one other thing. So I think I've located or understood what needs to be done to force all new objects to the cache tier, which is quite interesting because coupled with the lack of double writes now with BlueStore plus the EC overwrites, it means you're looking at about 4 or 5 times reduction in the amount of SSD wear. So that doesn't have quite as much as impact as it would have done 12 months ago, say. So I did try and compile a test version of that, but I'm having issues with package dependencies going all funny when compiling for Ubuntu Xenial. So I'm still trying to look at why that's doing that, but once I've got that, I'll try and do some testing.
I suspect that forcing all new writes into the cache tier is going to you're going to really, really be fighting with how much eviction traffic you have.
So it was only for new objects. So I on an RBD for an uninitialized block, or for CephFS like a new file, or right into a extending file.
Okay, so your workload wouldn't involve like a bunch of new creations of like RGW objects or Rados objects or something?
It does it in bursts, which is sort of why I was trying to sort of do this. So there's a period for maybe sort of 10, 20 minutes where it gets a very long string of small IOs. And then once that's over, it doesn't really matter anymore. So the idea was to probably increase the size of the cache tier to take this into account and just sort of try and absorb these bursts and then flush them to disks at a slower rate.
I see. Okay.
I think this is probably something that should be configurable per pool because I can, like you said, I can see that not everyone's going to want this.
Yeah. For that kind of workload, you'd almost want to anticipate that you've got these coming and like try to bring the cache to a like 80% full state so that you can like, or whatever you need, I guess, to burst them in. and then slowly, like get rid of stuff later.
Yeah.
Yeah, that's interesting. Certainly in workloads where you have like a lot of stuff constantly coming in, if you cache all new objects, it would pretty quickly like overwhelm the ability to evict stuff, and then everything slows way down.
Yeah, I think sort of what I see, because we've got quite a lot of spinning disks behind this. So in terms of bandwidth, if I'm doing like buffered 4 meg, I can get a serious amount of performance. But the actual incoming stream, because it's all sync writes and quite reasonably small, it might only be tens of megs a second. So it's more this sort of acting as a coalescing buffer type thing, which is what I'm trying to use it for.
A burst buffer. That was
Yes.
that was a real popular term like 5 years ago in HPC circles. Well, neat. I'll be curious to see if you can tune it to do well. That'll be a fun presentation. I'm curious. I'll be eager to see what you can come up with.
Okay, great. Well, as soon as I get it working, I'll put something together.
Cool. All right. Well, we're basically out of time, guys. So thanks for coming. See you next week.
Okay, bye.
See ya.
Have a good week,
See ya.
Phil.
Bye.